Hello all nighters. In this video I am going to discuss about the searching and insertion in PATRICIA. PATRICIA stands for Practical Algorithm to Retrieve Information Coded in Alphanumeric. It is an extension to the binary tree where the branch node and element node are combined to form a single node, and we call that single node as augmented node. Next, the PATRICIA is used in many fields. Some of the applications where the PATRICIA is used are NLP, natural language processing, and search engines. Now I am going to discuss about the searching operation PATRICIA. While we are performing searching on the PATRICIA, we have to remember two important things. That is, if we encounter a 0 bit, we have to move left, and if we encounter a 1 bit, then we have to move right. So first we have to start our comparison with the root node. Let us search for the element 1001. Let us assign bit numbers to this. So first we are comparing with the root node and we are going to the left. As we know that the root node has only one pointer and it is the left pointer, so we have to move only in the left direction. Now we have reached the second level. Here the bit number of this 0010 element is 1. So we have to check the first bit of our element. First bit of our element is 1. So we have to move right according to this rule. Now we have reached this level. Now here the bit number is 2. So we have to check the second bit of our element. This is 0. So we have reached to the next node. Here the bit number is 4. So we have to check the fourth bit, and our fourth bit is 1. So we have to take a right move. Now we have to stop this moving of the pointer until we get a self loop or we go to the node which is already traversed. Then we have to stop the search operation, and then we have to compare the element 1001 with the node where our search has stopped. So here the search has stopped at 1001. So we have to compare these two nodes. As they are equal, the search is successful and we have retrieved the element. Now I am going to discuss the algorithm for the insertion process in PATRICIA. So the first step is perform the search on the key. Suppose search terminates at S. So we are performing the search operation, and let us assume that the search terminated at S. Then create a node with key. And assign bit number to it, which is equal to the first bit in which S and R key differ. So this is called as the bit number, and it is the most important thing in the algorithm. So let us see how to find the bit number. Let us think that this is S and this is our key. So it states that bit number to which is equal to the first bit in which S and key differ. So we have to check from the left in both the nodes, and here 1 and 1 is common, 0 and 0 is common, and here we can see that the first difference is being occurred at third bit. So we have to assign j equal to 3 for our element which is to be inserted. This is the first step. See, we are going to do search operation twice. The first search operation is used to find the parent of the newly inserted element, and the next search operation tells us the link, or it tells us how to insert the newly inserted element. So now again perform search on the key with j minus 1 bits. Suppose the search stops at S after making a move from P to S. Then insert the key as child of P. So if our search is stopping at S by making a move from P to S, so this second search helps us to find the link. So here the search is stopping by moving from P to S. So we can see that P to S has a link, and so we have to insert our new key as a child of this P. It will be more clear when we are discussing with the example. If jth bit of the key is, and next we have decided the link of the inserted node. Now we have to decide the pointers of the newly inserted node. So to decide the pointers of the newly inserted node, if jth bit of the key is 1, this is the j, and if jth bit of the key is 1, then its right pointer will be self pointer. Its right pointer will be self pointer in this way, and the other pointer points to the S, and the other pointer points to its parent. And if the jth bit is 0, then its left pointer will be its self pointer. Jth bit is 0, then its left pointer will be self pointer, and the right pointer will point to its root element, that is S. If you did not understand the algorithm which was stated earlier, don't worry about it. By solving this example, we can get clarity of the algorithm. So first insert the element 1000, as this is our root element and the root element has only left pointer. So the left pointer will point to itself, and by default we will assign the bit number of the root element as 0. This is the insertion of the first element. Now let us consider the insertion of 0010. First, to perform the insertion operation on that, we have to perform the search operation on 0010. And as we know that the search terminates at the root node, that is 1000. So this is considered as the node S according to the algorithm, and this is considered as the key. So this is our key and this is our S. This is our root node. Now we have to find the jth bit of the 0010. Jth bit means the bit where the first difference is occurring between the S and key. Here as we can see that the first bit of S is 1 and the first bit of key is 0, as they both are different, and this is the first difference. We can name the J bit as 1 to our key. Now the second step of the algorithm is also completed, assigning the bit number to the key. Now we have to perform search operation on j minus 1 bits. Here j minus 1 bits means performing search operations on 0 bits. So we cannot perform search operation on the 0 bits. So we have to directly attach this element to the left of our S. So we are attaching to the left. And to determine the left pointer and right pointers of this newly inserted node, we have to check the bit number of the newly inserted node. It is 1 and it is jth bit, first bit of the node is 0. As it is 0, its left node should be its self pointer and the right node should point to the parent. And as we have to mention the bit number on top of the node, the bit number here j is 1. This is the insertion of the second element. Now we will do the insertion of 1001. Now this is the key. As usual, we have to perform the search operation on 1001 in this already constructed PATRICIA tree. So perform search operation. Compare with the root 1001. It's asking us to take left. So we have to go left. Here we have to check the first bit. Here the first bit of our key to be searched is 1. So as we know that if it is 0 we have to take a left move, and if it is 1 we have to take a right move. We are taking the right move to the root node. We have to stop the search if we encounter any self loops, or if we encounter the node which is already traced, we can stop the search. So the search is stopping it here. So now the S is this and our key is 1001. Now we have to repeat again the same process. We have to find the jth bit of the node. So jth bit means the first difference where these two bits are differing. Here 100, 100 is common and the 0 and this 1 are differing. So here the j value of this newly inserted node is 4. Now we have to perform the search on j minus 1 bits, that is 100 bits of the key. This first search is to determine the root, and this is our root, and the second search is to determine the pointer, like to which node we have to place a newly inserted node. So perform again search operation on 100. So again come here. Here it is telling us to go left, and here it is asking us to check for the first bit, and our first bit is 1. So we are going to the root node. See, again here our search is stopping. So the step where our search stopped, we have to consider that link as the new link where the inserted node should be inserted. So here our search is stopping by taking a right move from 0010 to 100. So this right move link will be the link to the newly inserted node. So we have to insert newly inserted node to the right of this 0010. Here the last move is from 0010 to 1000, and after that the search has stopped. So we have to remove that link, and we have to place that link and add our newly inserted key. Now we have added the newly inserted element. As a last step, we have to determine the left pointers and right pointers to this node. So this bit number is 4. Here fourth bit is 1. As it is 1, right pointer should be pointed to itself and left pointer should be pointed to our node. This is the insertion of the element 1001. Guys, you have to remember that the bit numbers will always be in the incremental order. Like this is the checking criteria where you can check that all the bit numbers should be in the incremental order. Next, let us insert the element 1100. Now this is our key, and again we have to start searching for that. So apply searching operation on this. Come to the root, take the left direction. Here we have to check the first bit. Then again take the right move. Here we have to check the fourth bit. Then it is then the bit number is 0. So it is asking us to take the left move. So take the left move. Then you will reach the root. So we can stop the search operation here. So for this element also the root node is S itself. Now we have to find the J value of this newly inserted node. Here as we can see 1 and 1 are common, and here 0 and this is 1. So the first difference is occurring at the second position. So J is equal to 2. So as the first step we have assigned the J is equal to 2 and the search is stopped here. Now we have to perform our search operation for J minus 1 bits. So J is equal to 2. Perform search operation for J minus 1, that is 1 bit, means only 1. We have to consider only first bit of the key. So as it is stating that first we have to again perform searching operation. Take left, then here we have to check the first bit. First bit is 1, so we have to take right, and we have stopped here. Here it is asking us to check the fourth bit, but we have considered only the one bit of the key. So our search stops here. And what is the previous link by which the search has stopped? This is the previous link by which the search has stopped. So we have to link our newly inserted node to the right of the 0010. We have to place this newly inserted element to the right of this. So we have placed this as the right of this, and now we have to find the pointers to this. So as this is the bit number is 2 and that bit number is 1, so we have to put the right pointer as its self pointer and left pointer should point to the 1001. And as usual 1001 has right pointer and left pointer pointing to the root. So in this way we have to insert our new element. So again we can observe that all the bit numbers are in the incremental order. Now let us insert the last element, that is 00, all zeros. So again start the searching operation. Search with the root node. It is telling us to take left, and here we have to check the first bit. First bit is 0, and we are taking again the same node. So we have to stop our process as we have encountered the self loop. So this is the root of the newly inserted element. Now assign the bit number to it. Compare 0010 with 0000. Here we can see that this third bit is differing. So the J value of this newly inserted bit is 3. Now we have to perform the search operation on J minus 1 bits to determine the link. So we have to perform search on 2 bits, 0, 0. Now we again start searching. We have to take left, and here we have to check for the first bit. This is left, and again we have to check for the first bit. This is left. So here again the search is stopping in the 0010 itself, and the previous link where the search stopped is this left link. So we have to place our newly inserted element to the left of the 0010. So place our new element to the left of this and assign its bit number as 0. As its third bit is 0, you should have a left pointer as a self pointer and the right pointer pointing to its root, that is 0010. This is the insertion process in the PATRICIA.